Hi guys, we're going to get a little bit further into geometry. Yesterday I had you look at a Khan Academy video so that you could go back and get a little bit of a refresher on triangles. We're going to spend some more time talking about triangles because basically you were just identifying what kinds of triangles there are. We still have to study the area of triangles, so we'll go back to that eventually, but I want to get a little bit further into quadrilaterals today. Before we start that though, I would like to do just a little refresher together on triangles and angles. So triangles with 3 equal sides are called equilaterals. Triangles with 2 equal sides are called isosceles. And triangles with no equal sides are called scalene. So triangles with all angles equaling less than 60 degrees, meaning it's just a little, I don't know how to do this, so you can see a little angle, okay? They are called acute triangles. Triangles that make, or angles I should say, angles that make an L or a perfect square corner are called right angles. And I can't even do it with my wrist. Triangles that open up bigger than 90 degrees but less than 180 are called obtuse. A 180 degree angle is just, it's a perfectly flat line, okay? All right, so when we look at these down here, this angle, this 110 degree angle would be called an obtuse angle. But this one right here, I can figure out how much this angle is without even having a tool to measure it, because when we see angles that are directly across from each other or right next to each other on a straight line, I know that this whole straight line is 180 degrees. So if this portion is 110, then this portion has to be whatever the difference is to get to 180. So 70 degrees plus 110 equals 180. So what is also true is that this angle and this angle would be identical. So this is also 110. And if this one is 70, this one is also 70. So what we have here when we look at this picture in general is these top angles are identical to these bottom angles, okay? So we've got 70, 70, 70, 110, 110, and down here 110, 110. I know that's a lot to take in, but we're going to practice it. We'll work on it together. Don't get nervous by that. All right, let's look at this problem. When colonists settled the land that would become the United States, ownership boundaries were sometimes natural landmarks, such as trees, rivers, and hills. Landowners who wanted to know the size of their property needed to estimate the area of their land. This is absolutely true. People would say, you know, my yard goes from that fence post to that big rock right there to that tree, blah, blah. So that probably caused a lot of arguments back in that time, and we definitely have a way better way of doing it now. But they did have to estimate their land ownership. So one of our vocab words is area, and area is the amount of surface a figure covers. We measure area in square units. So think of our classroom, our poor, lonely, empty classroom. If we were trying to figure out how much carpet it would take to cover the floor, we would need to know the area of that room, okay? So we're only talking about covering one surface, and it would be measured in square units, and more than likely in square feet or square yards, depending on who did the measurements. All right, so estimating the area of an irregular figure, if we're thinking about those colonists that said my yard goes from that post to that rock to that tree and whatever, they needed to estimate how big their yard was. So what we would do first is count the number of full squares in this picture. So we've got right here 1, 2, 3, 4 squares that are 100% shaded in. And then we would want to count the ones that are almost full. So here's one that's almost full, this one's almost full, and this one's almost full. So that's 3 additional squares. And then we would count the squares that are about half full, and this one is half full, and this one is half full. So if we took this one and put them together, we would have another full square. And then we don't count the ones that are like, there's almost nothing in it. So this one has almost nothing. This one has almost nothing. I know I personally would look at that and think, well, if I took all of these ones that have almost nothing and put them together, they might make one, but who knows? They're so awkward and the shape is so awkward, it's hard to really know if you would get another full one. So we just ignore that. So we would add up what we know for sure. We have 4 full squares, 3 almost full, and 2 halves, which equal 1 more. So 8 square units we would estimate that picture to be. If you guys don't know how to do area of 4-sided figures, I think you're going to really like this section because it's so simple and easy. All right, the area of a rectangle. To find the area of a rectangle, we multiply the length times the width. And normally you'll see it in your workbook if you have it. If not, you might hear me occasionally refer to it as length times width. And I know you guys have not learned cursive, but it's usually written in cursive, L times W. Remember, 2 things that are squished together with no space between them and no operator sign, like add, subtract, multiply, divide. If they're just squished together, that means to multiply. All right. So when we look at this one, we have length times width. Our length is 9 units. Our width is 4 units, so we have length 4 times 9, and we get 36 square units. You just multiply the 2 sides, 9 times 4. Now, sometimes you'll get a picture that it'll have the numbers listed all the way around. So it'll say 9 here, 4 here, 9 down at the bottom, and another 4 over here. You do not need to use all of the numbers. You only need 1 length and 1 width if they are identical. Okay? All right, parallelograms is a figure that looks like a tilted rectangle. Looks like this. We call it a parallelogram because it has 2 sides that are parallel to each other. Remember, parallel means 2 lines that go like this, and they could go on forever and ever and ever, and they would never touch or they would never cross each other because they are parallel. All right, so this is a parallel side. These two sides are parallel, and these 2 sides are parallel to each other. Okay, so this looks like a tilted rectangle, but if we take, whoops, I went too fast. If we take this end and we chop it off and we move it over here and put it, stop it. And we put it over here, it will make a perfect rectangle. And I'm going to show you that in the next picture, I think. So we can use the area for a rectangle to write a formula for a parallelogram, okay? All right, let's look at it on this one. So we chop it off and move it over here. And now look, we have a perfect rectangle. So we would just take our height and multiply it times the base. A lot of times in geometry, you'll see this dotted line, and most often it's either in this pink color or it's in red. And when you see that dashed pink or red line, that is almost always going to be the height measurement for any geometric figure that you're looking at. And it usually will have this little right angle box there to let you know for sure that that is your height measurement. So now we've created this regular rectangle, and we can use the formula area equals length times width or base times height. Just so you know, more often than not, I'm going to say base times height. I'm not going to say length times width because I know a lot of you don't know cursive. And so I'm not going to be using cursive. Base times height is the exact same thing as length times width. So let's try this out. So here we know that this is our height line, right? Our height line that goes from the bottom to the highest top point. The height is 3 inches. The base is 2 inches. Our formula is area equals base times height. So the base is 2 times the height of 3. So the area equals 6 inches squared. Area, remember, is always going to be in square units. So you need to be sure that when you're writing down your answer that you're squaring up whatever the unit of measure is. In this case, it's inches. In other things, it could be yards or meters or whatever it is. Square it up. All right, I would like you guys to return back to Canvas for your Canvas assignment. I'm always going to put it in the quiz tab. I have the scanned pages in there. You're going to have to do those pages from the workbook on your own paper and then transfer the answer into the question box that I've left for you in Canvas. Of course, if you guys need anything, please reach out to me, swolf2@district100.com. See ya. Have a good one, guys.